Hello, geometry students. Welcome back. Thanks for being here. Same as usual, Flipgrid is there. Go answer it. It's good fun. You have already found today's YouTube lesson, and now try this problem in your notes. And then unpause the video and do it with me. So, this problem asks me to solve the triangle and round decimal answers to the nearest tenth. That's important. Solve the triangle. Let's see, yesterday when we solved triangles, we used the law of sines. And I can tell that I have angle, angle, side here. And I know that whenever I have angle, angle, side, I'm going to use the law of sines. But what was the law of sines? Let me make sure that I remember that. The law of sines said that side A over sine of A, of angle A, is equal to side B over sine of angle B, which was equal to side C over the sine of angle C. Beautiful, beautiful. All right, so now let me see. Let me look at my diagram. Is there anything I can figure out without the law of sines? Wait a second. If I have two angles, I can find the third. So let me get this. 85 plus 29 is 114, and 180 minus 114 is 66. So angle C up here is 66 degrees. Fantastic. This is not a right triangle, so I can't use the Pythagorean theorem. I only have one side, so this is all I can do for now, until I plug things in to the law of sines right here. So let me do that. Let's see. This side, the side opposite angle A is side A. The side opposite angle B is side B. And the side opposite angle C is side C. That is always the case. That's how we name sides, is the angle and the opposite side have the same letter, but one is capitalized and one is lowercase. Fantastic. So, I do not know what side A is, but I do know that the angle of angle A is 29 degrees. I do know that side B is 9, and the angle is 85 degrees. I do not know what side C is, but I know that the angle C is 66 degrees. Wonderful, wonderful. Now, different color. It's not too bad for me to figure out what side A is, because all I have to do is cross multiply. Make our butterflies, and we have sine of 85 times A is equal to 9 times the sine of 29 degrees. Divide by sine of 85 here. And we get that A is approximately, oh gosh, whatever that is, 9 times sine of 29 divided by sine of 85 is approximately 4.4, because we're going to the nearest tenth here. Wonderful, wonderful. Okay. Cool. Let's get a new color in here. Now we're going to do the same thing with side C. Same thing with side C. C times the sine of 85 is equal to 9 times sine of 66. Divide by sine of 85, and C is 9 times the sine of 66 divided by the sine of 85, which means that C is approximately 8, that's what that says, 8.3. Ta-da! Now let me check that I have everything. I have all three angles, I can see that. I have side A, I have side B, and I have side C. So, we are donezo. Cool! Now that we're done with that, let's move on to what we have for today, shall we? We have our learning target and success criteria say, I know what... That should not say the law of sines. That should say the law of cosines. Oh my goodness. This should say the law of cosines. Oops! Well, I will go back and change that. Luckily, you're watching this video so that you know it's already changed if you're looking at it now. I will change that in a little bit. We are using the law of cosines today, and we're going to be able to use the law of cosines to solve triangles. So what is the law of cosines, you ask? Well, it's a little more complicated than the law of sines, in my opinion. This is the law of sines. Please pause the video and make sure that this is in your notes, and then we are going to talk about it. So, you'll notice that this kinda sorta looks like the Pythagorean theorem. If we just look at this chunk, it kinda looks like the Pythagorean theorem. And that's how I remember this. That's how I remember the first half, is I pick a side. That angle is the one I take the cosine of. So side a squared equals, and then I'm going to take cosine of that same angle. Then the other two sides. So if we're looking at A, the other two sides, I have b squared plus c squared minus 2bc. And this pattern is the same throughout. I have b squared cosine of b, and then I take the two other sides, a squared, c squared, and then 2ac. One more time, let's see that pattern. C squared and the cosine of c, and then I take the two other sides, a and b, squared, and then minus 2ab. So that's the pattern. It's a little more complicated than a over sine of a equals b over sine of b. So it's a little more complicated, but the more you use it, the more comfortable you get with it, and the better it feels. So, yes, that's all there is to it. You just gotta plug numbers into that thing, and you're golden. Yeah, if you want to know how this works or why this works, we can definitely talk, but I'm not gonna cover that explicitly in this video. Alright, moving on. Straight to the examples. We are going to look at the SAS case first. So this is where I have a side and angle and a side. I don't have anything else. So in this case, I cannot use the law of sines, sadly. If we tried it, it wouldn't work. We don't have enough information to be able to use the law of sines. So, we need to use the law of cosines. Alright, so we're going to solve the triangle, and we're going to round our decimal answers to the nearest tenth. Cool. Alright, so what I am noticing, the first thing I am noticing is that I have angle B, and I don't know what side B is. So the formula, the one of these that I'm going to use, I'm going to use this one. Because I'm looking for side B and I have angle B. If I had any other angle, if I had angle A, then of course I'd need to use this one. But because I don't have angle A, I have angle B, I'm going to use this one right here. I'm going to use b squared equals a squared plus c squared minus 2ac cosine of b. And we can scroll up just to make sure that we got that right. B squared, a squared plus c squared minus 2ac cosine b. Never hurts to check. Never hurts to check and make sure you're doing the right thing. Okay. Alright, so all we have to do is plug in our numbers to this bad boy. Let's make sure that we know what numbers are which. So remember, the side opposite A is side A, and the side opposite C is side C. Wonderful. So now, when we plug numbers into here, we have b squared, because we don't know what b is, equals a squared, a is 11 right here, plus c squared, 14 squared, minus 2 times a times c times cosine of b, which is 34 degrees. Okay. Whew! That looks like a lot, but it's not so bad. And there are multiple ways you can do this. You can just take this whole thing and put it in your calculator, and out pops you an answer. I would recommend doing that because you get less estimation errors that way. If I just do this part, and then I just do this part, and then I subtract what I get there, I'm subtracting a whole number from a decimal, right? Because cosine of 34, that's some big, long decimal number. So then I end up with just an estimation, and I don't want to make things worse. You don't want to estimate with an estimation, or it just keeps getting less and less precise. So I'm just going to take this whole thing and punch it into my calculator. So 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. So I get that b squared is roughly, right, roughly 61.6564, yada 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 yada. And remember, I still have b squared here. I just want b. I do not want b squared. So to undo that, I need to take the square root of both sides. So square root that, and I'm going to get that b is approximately 7.9. Beautiful. Wonderful. Okay. And now, it wanted me to solve the triangle. So I still need to find the other two angles, technically. What I recommend doing, Law of Cosines is messy. It is messy. Like, and I don't want to do that again. Especially since we'd be looking for angles, so we'd have to solve for cosine. Ooh, we're going to do that later. For now, the easiest thing for me to do would be to go back to the Law of Sines. Because this one's easier for me to use. I know how to cross multiply. I know how to use my beautiful butterflies. That feels comfortable and familiar to me. So, this is what I would do. A over sine of A equals 7.9 over sine of B, which equals 14 over the sine of C. Oh, and I forgot that we know what A is. It is 11. And we know what B is. It is... It is 34. So now, when we cross multiply, we're going to get 11 times the sine of 34 equals 7.9 times the sine of A. Divide by 7.9. 11 times sine of 34 divided by 7.9 is 0.77 yada yada. And that's equal to sine of A, so I need to take sine inverse of both sides so that I can figure out what A is, and I get 51.1 approximately. Okay, we can do the same thing with C. I am running out of space here. So, if you want to see C, it's on the next slide. You can hop onto my YouTube live stream, but I think you get the idea that the next thing we would have done was we would have cross-multiplied here, And it would have been the same thing, but we would have had C there instead, and 14 instead of the 11. Yeah, you get it. Alright, so let's move on. We can check our answers. Yeah, look at that. B was 7.9. Oh, we used the law of sines. Fantastic. Fantastic 51.6 is also what we got. And now, let's move on to the law of cosines SSS case. So this is where I have all of the sides and none of the angles. So, here, when we talked about which one are you going to use, which of the three law of cosines formulas are you going to use for this one, pick your favorite. Pick your favorite. Which angle do you want to solve for? You want to solve for angle A? You want angle B? You want angle C? Which one? Which one do you want? I want angle A. So I'm going to use a squared equals b squared plus c squared minus 2bc cosine of A. Cosine of A. Alright, now let's label. The side opposite A is A, the side opposite B is B, and the side opposite C is C. Now we're just going to plug all the numbers in there and I'll show you what to do next. So, A is 12 squared, B is 27 squared, C 20 squared minus 2 B C times cosine of, remember we don't know what A is. Okay, now this looks ugly, but don't worry. All we want in the end is A. We want A. So we're going to try to get this cosine of A all by itself. Think of it as like an X, and we're solving for X. That's what we're going to do. So, first let me figure out what these squareds are. 12 squared is 144. 27 squared is 729. 29. 20 squared is 400. Minus, I'm gonna figure out what this is. 2 times 27 times 20 is 1080 times cosine of A. Alright, let's figure out what these are together. I think it'll make things easier. 729 plus 400 is 1129 minus 1080 times cosine of A. Alright, and now we're gonna work to get this by itself. So I'm gonna subtract 1129 from both sides. That's gonna go away. 144 minus 1129 is negative. You can't see this because I'm in the way. Let me just move. Negative 985, which is equal to negative 1080 times cosine of A. And now, look at that. I can just divide by negative 1080 to get rid of that. And I get, let's see, I'm going to write it over here. I'm going to just write it over here so it's easy. 0.91 yada yada is equal to cosine of A. Ha! Perfect. Now, because I want to get the A by itself, I want to figure out what angle A is. I'm going to take cosine inverse of both sides. Cosine inverse of 0.91 stuff is equal to 24.2. That's a 4. Make that more pronounced. 24.2 degrees is approximately angle A. Woohoo! Alright, angle A has been found. Now, we want to solve the whole triangle. Woo! We want to solve the whole triangle, which means we still need to find these two angles as well. But remember, if I just find one of them, I can use the triangle sum theorem, and that'll make everything so much nicer. So, let's do that. And remember, I don't have to use the law of cosines again. Now, I can use the law of sines. So, let's do that. I want to solve for b. Personally, I want to solve for b. So we're going to take side b over sine b is equal to a 12 over sine of, now we know what angle A is. It is 24.2. And now we're going to solve for sine B. Whee! 27 times sine of 24.2 equals 12 times sine B. Divide by 12. Yeah! 27 times sine of 24.2 divided by 12 is 0.922 yada yada equal to sine B. And now, same thing as before, we need to take sine inverse of whatever that is equals 60, hey, be nice, 67.3 degrees, approximately, for angle B. Awesome, and now to find angle C, all I have to do is 24.2 plus 67.3, 4.2 plus 67.3 is 91.5, and 180 minus 91.5 is 88.5. So that is what angle C is. Whew! We have enough writing here? I don't know. I think maybe we should do some more. Just kidding. Fantastic. That is this triangle solved, because we have every side length. Every side length is here, and now every angle is here. So yay. Wonderful. Moving on. Can check our answers there if we wanted to. But we are going to move on to example 8, solving a real-life problem. An organism's step angle is a measure of walking efficiency. This is also true of other things in... Yes, we could get into that. Or you can watch the YouTube video on my personal channel of the talk that I did when I was in college. An organism's step angle is a measure of walking efficiency. The closer the step angle is to 180 degrees, the more efficiently the organism walked. The diagram shows a set of footprints for a dinosaur. Find the step angle B. Alright, so now all I care about is this angle. That is all I care about, is angle B. Wonderful. So I don't have to solve the whole triangle. Yay. Let's make sure that we are labeling correctly. The side opposite B is B. The side opposite angle C is C. And the side opposite angle A is A. Wonderful. Now, because I'm looking for angle B, I'm going to use this law of cosines formula. B squared equals A squared plus C squared minus 2AC times cosine of B. And now, remember, I am just going to plug in all of those numbers. So B was 316 squared equals A 155 squared, C 197 squared minus 2 times A times C times cosine of B, and I do not know what angle B is. Okay. Woo! If I square those numbers and actually write them all out, it's gonna be way, way, way too long. So I'm just gonna subtract this from this side. I'm just gonna subtract from this side. I'm gonna do it all in one step because, yeah, that is a lot. So 316 squared minus 155 squared minus 197 squared. That is still a ginormous number. Still a ginormous number. 337,022 equal to negative 2 times, in fact, okay, let's figure out what that is. 2 times 155 times 197. Yikes. 61,070 times cosine of B. Let's divide by that negative 61,070. Those cancel out, and now, oh, out of space. We're going to bring that up here. 37,022 divided by negative 61,070 is negative 0.606 da 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 equals cosine of B. And now, as usual, when we're looking for an angle, we're gonna go cosine inverse. Cosine inverse of the negative 0.6 da 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 is 127.3 degrees, approximately, for angle B. Okay. Awesome, so we found the step angle B. I'm also curious, the closer the angle is to 180, the more efficiently the organism walked. So this organism, or this dinosaur, apparently isn't walking super efficiently. But also, I'd be curious to measure a human's step angle and see how efficiently we walk. I'm very interested in this question, but I won't take your time right now to think about it. Okay, if you have questions about this, about any part of this problem, you know what to do. You know you should hop on my YouTube live stream, ask questions, email me, comment on this YouTube video, something. Any one of those things will do. Yes. Yes, indeed. And look at that. We were correct. Alrighty. Questions. Hey, what did we just talk about? What did I just say? I just said that if you have questions, you should do this. You should tune into my live stream from 12 to 2 p.m. each weekday. Today, I think we might sing. I'm in a singy mood today. Singing in the shower, singing making breakfast. So I think we may do some singing on the live stream today until you ask me questions, and then I'll stop what I'm doing to answer your questions. So tune in, hang out with us, have fun with us. Us being the people on the live stream. You know. Ask questions if you got them. Here is the homework. Zoomed in too much. Here is the homework for today. Homework, of course, right? In fact, this one we're not actually even gonna cover when we come back. Well, maybe we'll see. I don't know. Homework, is the point of that. Homework. All right, moving on to the last thing I have for you today, which is your launch. Comes from Teddy Roosevelt. Believe you can, and you're halfway there. I didn't realize how true this was until I started doing more things that I wanted to. In high school I did things I wanted to, but I also was just so focused on grades and working and preparing for college and stuff. But I mean, even with those things, even with preparing for college, if you believe that you can go to college, you're halfway there. If you defeat yourself, if you tell yourself like, "Oh, I could never go to college. I could never pass. I could never graduate high school. I could never." You're defeating yourself before you even try. If you tell yourself that, you're defeating yourself before you even try. Give yourself a chance. You are worth it. You are worth the chance. So give yourself the chance to prove it to yourself. Believe you can. Get halfway there, and then show yourself. Show yourself that you have what it takes, that you can. Because you do have what it takes. And you can. I believe in you, even if nobody else does. That is your launch for today. Take it with you as you go throughout your day. Thanks again for tuning in. Hope to see you on the live stream. And have a great rest of your day. Bye.